Hello and welcome to the Third Web Getting Started Guide. We're very excited to have you here, and I hope you are just as excited to start learning how you can utilize Third Web to build out your Web3 applications. In this guide, we'll walk you through how to use all of the core features of the Third Web product suite. We'll first walk you through building out your own Solidity smart contracts using the ContractKit. We'll build an ERC721A NFT collection with some special functionality. We'll deploy that NFT collection using deploy to a test network on the blockchain. From there, we'll show you how to connect and start interacting with your contract using both the dashboard as well as the SDK, which we'll use to build out a Web3 application to call some functionality and connect users' wallets to our application and start interacting in an application environment. We'll then walk you through the release tool, which shows you how you can release iterated versions of the smart contract we developed out to the public, where other people can view all of the information about their contract and also deploy a copy themselves. Before we jump into the video, I want to let you know that currently 70% of the amazing people like yourself that watch ThirdWeb's YouTube videos are still not subscribed to the channel. So before we begin, I'd love to ask you a favor. If you get any value out of these videos, I'd really appreciate it if you subscribe to the ThirdWeb channel. And a little tip is we're going to be airdropping 10 users who have subscribed to the ThirdWeb channel a very special NFT every week. And before we begin, remember you can always see the full source code in a sandbox, which will be in the link in the description if you want to just jump into the finished product and explore the code yourself. With that said, let's get right into the building. The first thing we're going to build is a smart contract. And the smart contract is the foundational layer for any of your Web3 applications. It's responsible for storing all of the state as well as the logic of your backend of the project, all stored on the blockchain. At ThirdWeb, we provide a variety of different ways for you to build and deploy your smart contracts, ranging from audited, gas-optimized pre-built solutions to a full set of Solidity smart contracts that provide the building blocks for you to create and build your own. In this video, we're going to be using the Solidity SDK or the ContractKit to build out our own smart contract using a Solidity development environment. If you're interested in checking out some of the contracts that we have pre-built for you, there'll be a link in the description where you can get a summary of all of the ones available. The absolute first thing that you want to do when you're building out a Solidity smart contract is to use the npx thirdweb create -- contract command. And this allows you to build out a brand new Solidity project where you'll be able to select a name first of all. So let's give our project a name of just contracts, and you'll be able to select a supported framework. For this video, just to keep it simple, I'm going to select the Hard Hat framework. Here's where you get to choose one of the base contracts that we have available as part of the ContractKit. And you can see a full list of all of the base contracts available in the extensions documentation here. We'll be able to see the ERC721, 1155, and 20 base contracts that we have, and these provide a set of features that have logical implementations as a kind of starting point for you to extend or modify and build upon as the foundation of your smart contract. In this video, we're going to use the ERC721 base smart contract, which provides us a implementation of the ERC721A NFT optimization. You can see in the documentation here, we have this implementation of the Azuki variation of the ERC721 standard, which provides some gas optimizations when you're minting multiple NFTs at once. We have things like the mintable feature available, batch mintable. We have metadata on that contract, as well as the ownable, which just gives a wallet address that owns the smart contracts. And we can also set royalties on this ERC721 contract that we're implementing here. And if we go back to the CLI, we can change directories into that contracts folder. We can open this up in our text editor here. Inside the contracts folder, you'll notice a file called contract.sol, which is our Solidity file. You'll notice that we have kind of three things going on within this file. The first thing is we're importing the base contract called ERC721 base. The second is that we're implementing that contract by saying our contract is that ERC 721 base. And the third thing is this constructor here. And this is just the implementation of any of the required functionality to successfully implement that contract. So this is a requirement to successfully implement the ERC 721 base command. And when you think about it, it kind of makes sense because our contract needs to have a different name for the smart contract, a different symbol, a different royalty recipient, so a different wallet address that is actually receiving those funds. And here we can also configure the royalty BPS, which is the basis points of how much we're taking from those secondary sales. So for example, if we set this as 500, this will be a 5% royalty fee on secondary sales in this smart contract. This pattern lets us implement all of the logic and the functionality in another smart contract into ours. So for example, if we click into this code, we can see all of the logic of the ERC 721A standard, as well as all of those features we saw on the portal, such as the mintable and batch mintable, as you can see, are implemented in this contract. And all we're doing is essentially bringing that into our contract called contract here. And we can feel free to rename this to something like my awesome NFTs. And now our contract is always inheriting all of the logic that we've imported and implemented by saying our contract is ERC 721 base. So if base contracts are the starting point of your smart contracts, where they give you a kind of logical set of features and implementations for you to build upon, how do we actually add features into our smart contract? There's two kind of different ways that you can do that. You can add some of the features available as part of the ContractKit, or you can add your own functionality within this contract if you choose to do so. The first thing that I'm going to show you how to do is import one of the features that we have available called permissions. Now, permissions allows you to restrict who can call specific functions inside of your smart contract based on their wallet address. So we'll create a role, we'll provide a wallet address that role, and then anybody who has permission or has been granted that role will be able to call specific functions inside of our smart contract. To do that, I've gone to the features section, general extensions and permissions here, and I've gone down to the permissions enumerable contract. And this allows us to iterate over all of the roles and see which wallet addresses are part of each role, hence this enumerable part of the name here. So as we can see, we can follow a similar pattern where we import the smart contract here. So let's copy and paste this import it into our contract. And then what we need to do is say our contract is both ERC 721 base as well as permissions enumerable. And then we need to import or implement any of the required logic to satisfy this function. So we can see in this implementing the feature here, we define a role called number role. We set a function that only role here of the number role can call the set number function. We're going to make our own little modification of that, and we're just going to use the default admin role within the constructor here. So in the constructor brackets, let's set up the default admin role and provide that role to the wallet deployer. So when the person that deploys this contract deploys it, they'll be granted with the default admin role. And we can do that by accessing the setup role function here and using the default admin role as well as a message.sender, which is the wallet address that calls this constructor function, which essentially just means the wallet address that deployed this smart contract. So when this contract gets deployed now, this setup role, which is exposed by the permissions feature here, will be called on the default admin role. So we're providing default admin role to the wallet address of the person or the wallet that is deploying this smart contract. Now we're going to add some custom logic to our ERC 721 NFT collection. So the first thing we're going to do is we're going to create and assign a power level to each of these NFTs. To do that, we can create a mapping from token ID or the NFT ID to the power level. So let's create a mapping here that says mapping from token ID to the power level of that NFT. And this is going to be a mapping from uint256, which is the number format for the token ID, to another uint256, which we'll use for the power level. And this is going to be a public mapping called underscore power level. Let's get rid of the underscore here. Suggest this is a public variable. And next, let's create another function that allows the admin role to update the power level. So let's down here say, add a function to set the power level. This function is only callable by the admin roles, admin members. So let's call this function set power level. And this is going to accept first the token ID of the NFT we want to update. And this is going to be of type uint256 token ID. The second parameter is going to be that power level as it's suggesting here. And we're going to restrict who can call this function by using the only role modifier. And in this only role modifier, we can pass the default admin role is the person or the persons that can call this function. And within this function, what we're going to do is set the power level of the token ID that got passed in as a parameter. So here we're updating the mapping of power level with the key of token ID. So within that mapping, we're updating token ID to be equal to the power level here. It looks like we just need to clean this function up a bit here. And there we go. We've successfully combined the base contract with the features as well as our own custom functionality. The final kind of modification that you can make to a smart contract that you're inheriting is by overriding some of the functionality inside of that contract. So for example, inside of our ERC 721 base, we have a function called mint2. Now let's say I wanted to override some functionality within this function, but I still wanted to keep the minting capability of this smart contract. Let's go back to our contract.sol file, and let's say we want to override the mint2 function of the base contract. And what we're going to do within this function is we're going to update the power level of each NFT as it gets minted to be equal to the token ID that we're minting. So for example, if token ID 1 is about to be minted, we'll set that NFT's power level to have a power level of 1. And let's add a quick comment here. So set the power level of the token to be the power level of the token ID. And this is going to override the mint capability. So if we go here into the base contract and we copy this capability, paste it into our smart contract, and then we just add the override keyword, we've now overridden the logic of the base contract to use whatever we put inside of these curly brackets here. So for example, at the moment, if somebody calls mint2, this smart contract is going to do nothing because we don't have anything inside of these curly brackets here. So the first thing we're going to do in this function is to grab the next available token ID. And we can do that using a variable provided by the smart contract called the next token ID to mint function. And then what we're going to do is we're going to actually mint the NFT using the underlying logic. And beneath that, what we're going to do is set the power level of that NFT. Now you can see how we're kind of injecting our own custom logic into the existing function, where now we can say super, which refers to the base contract that we're inheriting. So in this case, super refers to ERC 721 base. And we're going to call the super mint function. So mint2, and we'll pass the same parameters in here. So now we're saying grab the token ID, continue with the rest of the mint capability inside of this mint2 function, and then we'll set the power level of that NFT. So what we're going to do is we're going to say power level of token ID is equal to token ID. And now we've kind of injected and overridden the logic of the base contract to append our own custom logic interacting with other parts of the smart contract that we've added inside of this contract.sol file. So now let's say we're happy with our smart contract and we're ready to deploy it to the blockchain. All we need to do is open up the terminal, and we can either run the npx thirdweb deploy command, or you'll notice with the default project, we get a build command, a deploy command, and a release command that runs these underlying detect, deploy, release commands from the thirdweb CLI under the hood. So before we deploy, let's run the yarn build command, or if you don't have yarn installed, you can run npm run build. And as you can see, this is going to first ask us to install the latest version of the thirdweb CLI. And then it's going to run the npx thirdweb detect command. And this is going to detect all of the features that we've successfully implemented in our smart contract, which means we'll be able to use all of those features inside of the SDK. And we'll learn a little bit more about what that means when we start to build out the application. So you can see within the My Awesome NFT smart contract, we've successfully implemented all of these ERC 721 features, such as supply, mintable, batch mintable, burnable, as well as the base standard. And we also have functionality available with the royalties that come with the base contract, the permissions, which he implemented with the permissions enumerable. We have contract metadata as well as the ownable feature. And beneath that, it suggests some other extensions, that you might want to implement, such as ERC 721 enumerable, lazy mintable, and signature mint. And you can learn more about what each of these means just by clicking into these and opening up the portal. So for example, if we implemented the enumerable extension, we'd be able to see a wallet address and which of the NFTs within this collection that wallet address owns. So you can go ahead and see if you successfully implemented any of the extensions that you wanted to implement, and you can learn more about all of the available extensions from the thirdweb portal. But let's say we're happy with this. All we need to do is run the yarn deploy or npm run deploy or npx thirdweb deploy if you want to use the CLI, as it is running for us behind the hood here. What this does is first it detects the project type. As you can see here, it detects that we're using Hardhat. So it uses Hardhat for the next step to compile our smart contracts, successfully compiles them. It's starting to process each individual smart contract that we have within this project. So as you can see here, it's processing the My Awesome NFT smart contract. What it's doing now, if we open up the folders here, you can see that it's building out these artifacts where we have these contracts such as My Awesome NFTs.json. And within here, it's building out the ABIs, uploading those ABIs to IPFS. And when that process is done, as you can see here, it spits out a link for us. And if you're on Mac, that link should automatically open up for you and opens it up in the thirdweb dashboard. And once this metadata loads, let's go ahead and connect our wallet as well while we're at it. Just enter my password. You can see again all of the detected extensions that we have here, which leads to this extensions page. And we have all of these features successfully implemented in our smart contract. Now here's where we get to actually deploy our smart contract to the blockchain. And we just need to provide all of the constructor parameters that need to be populated when we go to deploy this actual contract. So for example, here we have the name, which is just going to be the name of our smart contract. So let's say Awesome NFTs. Awesome NFTs. Let's give it a symbol of awesome. The royalty recipient is the wallet address that you're going to send the royalties to. So for example, I'm just going to copy and paste my wallet address in here, and I'll set a 5% royalty fee for the NFTs or the secondary sales of these NFTs to go to this wallet address. So here we have kind of the contract metadata where we have the name, the symbol, and here we have the implementation of the royalties, and we're setting that up as we deploy the smart contract. Beneath here, you'll have the section where you choose the network and the blockchain that you want to deploy to, and you can learn more about which blockchain you might want to choose and how you get the test funds available if you want to play around on test nets and deploy smart contracts without using any real money before you go to the real thing. And then with the add to dashboard checkmark here, you can choose to add your contract to the dashboard, where you'll be able to go to thirdweb.com/dashboard, and you'll be able to see your contract within this list of contracts here. For me, I'm just going to approve one transaction to keep it simple. So I'm going to uncheck that box, and then I'm going to select the Goerli Ethereum test network to deploy my smart contract to. Once you're happy with the constructor parameters and you're deploying to the network of your choice, let's go ahead and click to deploy now. Here, it's asking us to switch networks, and then let's click deploy now. Let's go ahead and approve the contract deployment transaction here. And our smart contract has successfully been deployed. So you can see here within the dashboard, we have a graphical sort of user interface where you can view all of the functions of your smart contracts and many, many other things as we're about to explore now. Within the Contract Explorer, you can write transactions and read data from the smart contract directly through the dashboard using your connected wallet. So for example, if I wanted to check the balance of my wallet address, I could paste my wallet address in here as the balance of owner parameter. And obviously this is going to return 0 because we don't have any minted NFTs yet. And you can see that comes back as 0. If we wanted to set the owner of the smart contract, we can execute transactions directly from this dashboard here as well. I'm just going to go ahead and reject that transaction, but just so you can see if that transaction goes wrong, the errors that get printed out will show up on the UI here as well. So you can see contract transaction failed, user rejected the transaction. And here's all of the information as well as how to kind of address resolving that issue. Within the events tab, you can see all of the events that got emitted from your smart contract, as well as the block number and the transaction hash that those events were emitted at. So for example, you can see when we deployed the smart contract, you can see that role granted event was emitted when we set up that default admin role with the message.sender address. Within the NFTs tab, this is an unlocked tab based on the features that we've implemented inside of our smart contract. So since our contract implemented that ERC 721 feature, we now unlock the NFTs tab. And since it implemented the minting feature of the ERC 721 standard, we also unlock this mint button here. So you could go ahead and mint a new NFT, and let's say my cool NFT. Let's go ahead and upload a file here. Let's upload my beautiful face here. Let's say my head is the description of that NFT. You can upload all of the metadata such as the properties, which you could use to create a PFP NFT collection if you choose to do so. I'm just going to keep it simple and mint this NFT here. And while that's minting in the background, go ahead and approve the MetaMask transaction here. And it looks like that transaction has gone through. And if we go back to our NFTs tab here, you can see NFT minted successfully. And now instantly that NFT and the metadata is pulled down from IPFS. So when we minted that NFT, the metadata goes up to IPFS. It's pinned in IPFS for you behind the scenes. And now, since we've implemented that ERC 721 supply function, we can view all of the NFTs available in this smart contract, as we can see in this section here. So since we also implemented permissions, you can see we have this permissions tab unlocked. We also have the code tab where you can learn in different languages of the SDK, how you can connect to and interact with your smart contract, as we're about to do in the next section here. You can see the settings where we have the contract metadata and royalty features unlocked as we implemented those in our smart contract, as well as the source code tab here, which is going to show you the full Solidity source code. If you go to contract.sol here, you can see here is all of that code that we wrote inside VS Code, as well as the code of all of the dependencies as well. And if you're on a mainnet environment, you can actually verify your source code or your smart contract with one click with this button here. It doesn't work on a testnet as it's not supported on Goerli right now, but if you were on a mainnet environment, you can easily verify your smart contract here. So if we check on our Contract Explorer here, we should be able to see the power level of the NFT that we just minted. So let's see, we have set power level here as the write function, but let's take a look at our mapping here where we have power level. Let's take a look at the NFT that we just minted, and the NFT of token ID 0 should have a power level of 0 here, as we can see. So the power level of the NFT that we minted is equal to its token ID. So if we minted another NFT, that power level would be equal to 1. So you can see how useful the dashboard is when it comes to getting an overview and managing what's happening in the smart contract that you have deployed. Now we're going to move back into the CLI here. Now let's change directories back into our project where we created that contracts project as well. Let's run the npx thirdweb create command again. But this time, instead of creating a smart contract, let's create an application. So let's pass the --app command, or the --app flag, sorry. We now also get to name our project. So let's call this application. Here's where we get to choose the framework we want to use, as well as the language we want to use. So for me, I'm going to use the Next.js language, the Next.js framework, and the JavaScript language options here. And what this does is it sets us up with a very basic boilerplate project with the thirdweb JavaScript or TypeScript SDKs installed, as well as the thirdweb React SDKs installed. And you can learn more about those SDKs in the SDK section here. And you can see all of the functionality available, like setting up the SDK, using UI components to perform common actions within Web3 applications, such as connect users' wallets, call functions on the smart contracts, as we're going to do, use the media renderer components to view and display the relevant metadata of the NFTs on the UI, as well as interact with all of the individual features that we've implemented. So for example, we implemented the ERC 721 standard feature, so we could use all of these functions within the SDK. We also implemented all of the supply functions required for ERC 721 supply, so we could use ERC 721.getAll to view all of the NFTs in the smart contracts. And the best thing about the SDK is it abstracts all of the complexity away for you. For example, in this view all function, in a typical Web3 application, you might have to iteratively fetch all of the metadata from IPFS, retry any of those failed requests, organize them in sort of parallel if you want to be optimized, place them into an array. Then you would have to make another request to get the current wallet address that owns each of these NFTs. You'd have to also merge those into the array that you're returning. And it just becomes really complicated in a Web3 application where you have so many of these moving parts with metadata coming from external services like IPFS. You have to use an RPC to connect to the actual blockchain to load that information. You'd have to use a gateway to serve the IPFS metadata onto the UI. And all of this complexity is abstracted away with just one line that does all of that logic for you. So this is why I personally love the SDK so much, is because so much of that sort of annoying specific Web3 capabilities that you need to implement to have a decentralized application is just available in this really easy to use, user-friendly interface for us here. So in the background, we have set up a simple application. So let's change directories into the application folder here. And let's open this up. If we take a look at the pages folder here, we can see we have two pages. One is this _app.js page, which if you're not familiar, this is the page in Next.js that wraps our entire application. If you're using Create React App, this will be called index.js. So they kind of swapped between in Next.js and Create React App. But essentially what's happening here is we're wrapping our entire application within this thirdweb provider component. Now this is a provider that gives all of the pages in our application all of the necessary context that it needs to run the hooks of the React SDK as well as the UI components of the SDK. So any page within this thirdweb provider, which in our case is every page, will be able to access all of the functionality that we're going to use in the React SDK. And you'll notice here on line 4 that we're declaring an active chain ID, which is essentially the network that we've deployed our smart contracts to and that we want our users to be connected to when they interact with our application. So if you remember in the first step, we deployed our smart contracts to the Goerli test network. So let's go ahead and change that from Ethereum mainnet to be the Ethereum Goerli test network. And the other page that we have available here is the index.js page. And this is just the homepage of our application. And since we are living within that thirdweb provider component, and we're wrapped within that thirdweb provider, we can use the UI components such as the connect wallet button, as well as any of the helpful hooks that we have available in the React SDK. So let's go ahead and show you some of those hooks now. The first one I want to show you is the use contract hook. And the use contract hook, as the name suggests, allows you to connect to your smart contract. And the way that we do that is by destructuring the contract field that gets returned out of the hook that we're about to use. So we can say const contract is equal to use contract. And the value that need to paste here is the contract address. So if we go back to the dashboard here, we can go ahead and copy that address to our clipboard by clicking that address there. And then all we need to do is paste that smart contract address in between those brackets. And that's literally all we need to do to connect to our smart contract. So from here, we can see if we look at the contract variable, we have all of this functionality available to us, like the ERC 721, for example, where we could access balance of, we can access the mint button, we can access the get all functionality. But what we're going to do is we're going to showcase the different ways that you can actually read data and call transactions on your smart contract. One way to do that is to call the contract.call function. And you can see here, all you need to pass in is the function name as well as the parameters inside of the other arguments. The other way you can do it is using the useContractRead, which, as the name suggests, allows you to read data from your smart contract. And we can do that by destructuring the data that gets returned out of the useContractRead hook. And what we need to pass in here is, first of all, the actual contract itself, and second of all, the actual function name. So let's say we wanted to view the name of the smart contract. We can pass the name of the view or the mapping or the function that we want to read from that smart contract. We're destructuring the data. If you're not familiar with this pattern, these hooks are using React Query under the hood, which provides a lot of additional benefits such as the caching of results, the automatic retrying of these queries, as well as when we go to mutate the information on our smart contract, these hooks will be automatically updated, or that cache will be invalidated to re-query the data to grab the latest information from the smart contract itself. And we can go ahead and rename the data here to be something more meaningful, like contract name, just by using this colon and renaming that variable here. So now we can access the name of the contract with the variable here called contract name. So that's how you read data from your smart contract. How you write data to your smart contract is by using a similar pattern. We're going to use the useContractWrite hook this time. And instead of destructuring the data out of the useContractWrite hook, we're going to destructure the mutate if you want to have a synchronous version of the function. So you can say set contract name here, for example, is equal to set name. I'm not sure if that's a valid function, but we're not going to use this function anyway. I'm going to show you how we can use the Web3 UI component to call the functionality of our smart contract. The other way you can do it is you can use mutate async and rename that to get a function that you can await the value of and grab the result after awaiting that function's call to be completed. So let's go ahead and get rid of the useContractWrite here. I'm going to show you another way you can actually write transactions on your smart contract, which is using the Web3 button component. So let's go ahead and replace our Connect Wallet button here with a Web3 button. So let's add the Web3 button here. And the two things we need to pass within this component are first the contract address, and we can just reuse this variable here. You could extract it out. Let's do that. Let's say const contract address is equal to this value here. And then let's reuse that variable within the useContract hook, and let's reuse it in here, contract address. Excellent. And now the second thing we need to pass is the action. So let's add the action in here. And the action is what happens when you click this button. And we'll get to that in a little second here. Let's just give this button a name. Let's say mint an NFT. And what this Web3 button does is when you press it, it does two checks before actually running this action. The first check is to make sure there is a connected wallet. And if there's not a connected wallet, this button will actually transform itself into a connect wallet button, which allows users to connect with MetaMask, Coinbase wallet, as well as a variety of other different wallets to your website. And once the wallet is connected, they'll first be asked to switch to the network that we defined in this active chain ID here. And then it will run the actual action that was called once they're on the correct network. So this is a really helpful button that makes sure your actions are going to the right blockchain, because there are some pretty unexpected behaviors if your smart contracts are being called on the incorrect network. So within this action, we actually have access to the contract within these parentheses. So we can access the smart contract that we're connected to within this function here. So you could say console.log contract or contract.whatever you want to call, which is what we're going to do. So we're going to access contract. And since we've implemented the ERC 721 standard, we can access ERC 721 and we can call any of the available functionality or the features that we've implemented. So if you remember, we implemented the ability to mint. So let's call ERC 721 mint here. And then the prop that we need to provide is the metadata here. So let's mint an NFT that has the metadata of name is equal to hello world, a description of hello world. This is the description. And then for the image, you can either pass in a file or a URI or a URL that points to any valid image here. And all of this metadata will be pushed up to IPFS and pinned in IPFS automatically for you as soon as you call this mint function here. And all of that complex logic will be handled by the SDK. So let's go ahead and maybe let's just grab this image address. For example, let's copy the image address here. In a real world, you'd probably want to add a file or let the user upload a file. It's just a little bit complex. We're just going to keep it simple in the string where we're uploading a image from the web here. So that's all we need to do to mint the actual NFT. And if we go to the terminal here, we can test this out by running yarn dev or npm run dev if you don't have yarn installed. And at localhost 3000, you'll be able to see we first have this connect wallet button that's taking up the full width of the screen here, as that's the default behavior. And we have, if we go to incognito mode, we should see this connect wallet button that allows you to connect with Coinbase Wallet, Wallet Connect, and MetaMask. And let's quickly go back to our application just so it looks a little better. Let's add a div with a max width of 200 here. And this will take up the full width of the div. If we go back to our application here, this looks a bit more reasonable. And let's go ahead and zoom in. So you can see the default state of this button, if I don't have my wallet connected, is this connect wallet button here. And you can add any styling customization you want. I'm just keeping it simple here. But what you can do is when you have connected your wallet, so for example, if I go to a browser where I have connected my wallet to localhost 3000, I'll see this mint an NFT button, which is the actual Web3 button that we're going to run. And with this mint and NFT button, when we click it, it's going to spin until the result of the function that you put within the action is completed. So for example, if we want it to spin until the mint is complete, all we need to do is return the result of that function. So instead of having curly brackets here, we could just return the result of the contract.erc721 mint here. And you could convert this to an async function if you choose to do so and have await statements in there. But for us, all we need to do is just return the ERC721 mint result. So if we go back to the UI and we click the mint and NFT button, you can see it's spinning until that result is complete. And in here, we're uploading the files to IPFS. It has been completed. And then we have this prompt to accept the mint transaction. Let's go ahead and confirm that one. And until that function is complete, this button is disabled and gives us this nice loading icon to suggest that this transaction is still going on and you can't repeat that until the process has been completed. And once this transaction goes through, what we'll notice in the dashboard here is that our NFTs have been minted. So this transaction has just gone through, the button goes back to its normal state, and we have minted that new NFT. And that data automatically gets loaded into the NFTs tab here. Now, what if we wanted to show all of the NFTs that have been minted into the contract on the UI? Let's go ahead into our application here. And beneath the div here, let's make another div to say div. Let's grab all of this into another div. And within this div, what we can do is use some of the specialized functionality that we unlock inside of the SDK to load all of the NFTs. So if you can remember on the portal here, we have this view all feature that we've unlocked by implementing ERC721 supply. And if we go to the React tab here, you'll notice we have the use contract hook, but we also have this use NFTs hook, which has been unlocked for us since we implemented this functionality inside of our smart contract. So we can use the use NFTs hook, and we'll just copy and paste this into our application. Let's paste this beneath our contract here, and we can get rid of the filter. Just get all of the first 100 NFTs. And again, you can see this is a almost identical pattern to the use contract read hook, but what we're doing is use NFTs returns this object that returns the data, which contains all of the NFTs as well as the metadata and the owner of each NFT that is automatically pulled from IPFS and fetched, all provided into a single array for us. All of that information is cached. So when we make this a query again, all of that information is going to load really, really quickly. And we also get these convenient flags to suggest, did something go wrong fetching that data? And is that data still loading from the blockchain? So is loading will be true while that data is still being fetched. Once it comes back, it will be available as an array within this data field, which we're renaming as NFTs. So within our UI here, let's go ahead and say if is loading, then let's return just a simple div that says loading. But if it's not loading, then we'll iterate over all of the NFTs within this NFTs array. So we can open the NFTs here and we'll say nfts.map, which is a function that allows us to loop over all of the NFTs. We can access the current NFT that we're iterating on within this field here. And let's transform each of the NFTs into their metadata. To do that, we're going to use the UI component called the NFT media renderer, which I believe is called, oops, looks like we need a comma here, thirdweb NFT media. So we've imported thirdweb NFT media within this open brackets here. What we can do is we'll say return the thirdweb NFT media renderer component. You can see the only thing we need to pass here is the actual metadata of that NFT. So let's pass metadata is equal to nft.metadata. We'll close that component off. And React wants us to put a key, so let's put nft.metadata.id as the key here. Let's convert that to a string as well. Excellent. All right. And then, so now we have the image. We can add any kind of styling we want here. So let's say we want it to be reasonably sized. So let's say width is equal to 200 pixels. And then beneath the thirdweb NFT media, let's add a p tag here that says the name of the NFT. So we can say nft.metadata.name. And there we have it. That's all we really need to do to load all of the NFTs onto the UI. And if we go to localhost 3000 here, you can see we have that loading text as the information is coming back. And as soon as that information has loaded from the blockchain, that data or that NFT field, as we're calling it, is populated with the metadata of each of the NFTs in this smart contract. And then we're able to render all of the NFTs, fetch that metadata from IPFS and render the correct element on the HTML side of things. So for example, if we had a video tag for one of these NFTs, these would be rendered as videos on our HTML. But as ours are both just images, we have an image for the original NFT that we made using the dashboard. And then we have the NFT that we made using the SDK here. And as you can see, we have this connect wallet button component where we have the three options here. And what I'm going to show you now is how useful these hooks are when it comes to having a very, very great user experience when you make transactions, because the data of these hooks gets updated every time you use the Web3 button to update the state of your smart contract, or you use the use contract write hook or one of the customized use hooks. For example, there's a hook for use mint NFT. Whenever you call these write transaction hooks, the data of the read hooks is updated and says, okay, there's now new data available for me to read. Let's requery and update that information. And that will be immediately rendered on the UI whenever there's new data available. So for example, if we go back to our app here, let's re-click the mint NFT here. And this is going to mint the Hello World NFT here with the nice little triangle image as we paste it into the image metadata. It's going to upload that information to IPFS. It's going to pin that metadata for us behind the scenes. It's then going to re-query the data to get all of the NFTs from that use NFTs hook. And then it will immediately, once this transaction goes through, show that new NFT on the UI. So the transaction's just gone through and now our NFT is immediately shown to us on the UI as that query is rerun for us. So now that we've learned how to build a smart contract, deploy it to the blockchain, and then build an application on top of it, let's learn about what Release is. So Release is a product built by thirdweb that addresses the gap in Web3 of the traditional software development workflow, where you improve your code over time and release these incremented versions of your software that allow people to utilize your smart contracts, typically through a registry such as NPM. Release is bringing this registry to smart contracts and is a on-chain registry where you can publish the smart contracts that you're building onto the blockchain and have other people view both the metadata of your smart contracts as well as a profile that you set up to deploy the smart contracts that you're creating, as well as view all of the features, the functions available, the source code, the metadata, and release notes for each iteration of the smart contract that you release. So now I'm going to show you how we can release the smart contract that we built in the first section. If we go back to our CLI here, and let's change directories back into the contracts folder, all we need to do is run either yarn release or npx thirdweb release to use the CLI directly. And very similar to the deploy command, what this does is compiles your projects into their ABI form, uploads those ABIs to IPFS, and then opens the dashboard for us to release our smart contract onto the registry. Now, instead of deploying directly to the blockchain, we create a iterated version of the smart contract code itself. And we'll be able to upload metadata like a name for our release, a description for our release, and release notes, as we can see in the form that gets generated from that link here. We have the metadata uploaded. We can upload a logo. So let's upload, again, my face here for the metadata of the NFT. And we can provide a description. Let's say this is a description for the getting started contract, and then we can add any markdown. So very, very similar to publishing your code to GitHub or to NPM. And let's say a heading here is my awesome NFTs. Don't worry about the spelling. And then we can add any markdown that we want here. So we can add links and images and all kinds of things. So let's just keep it simple and say getting started. We can preview what that markdown looks like if you spell your awesome correctly here. And then down here, we can use semantic versioning to release a version number of this smart contract. So every time you release a version of this specific named contract here, so let's say I went back to the Solidity code here and I messed it up. I made an addition here to say this is now private. I would then re-release it and iterate the version that I'm releasing. So then I would release version 1.0.1, and in here I could say release notes are I changed something from public to private. And everybody can see each version you release with different title, different description, different image, and the metadata gets uploaded to each version. So let's go ahead and release our first version of the My Awesome NFTs contract here. Let's click release contract. And all we need to do is sign the gasless transaction here, which simply put just means thirdweb is paying for the gas for you to release your contract. And our registry is currently on the Polygon blockchain. So all of this metadata about your contract, as well as the source code of your contract, the wallet address that is deploying and releasing this contract onto the blockchain, which is currently stored on the Polygon network. So I'll go ahead and approve that gasless transaction here. And as you can see, that release has been successful. And here's where we get taken to the landing page that gets generated for us, where we can see all of the metadata that we just uploaded. So we have the image, we have the title, the description. We can edit all of this information by creating a new release. We can see all of the source code, the events, the functions available in this smart contract, as well as the details such as the license, the date it was released, the releaser profile. So here's my test account. On my profile, you can see all of the other contracts that I've released. And if you have an ENS domain, this actually automatically gets set to your ENS domain. So you'll be able to see, for example, jarrodwatts.eth is my main account. You can see all of the smart contracts that I've released onto that account. You can set up your social media profiles as well as any other information that you want on your profile. And now you can actually share this page as the landing page of your smart contract and allow anybody else to deploy the smart contract from one click up here onto any of our supported networks. So let's go ahead and deploy it now. You'll see we have a very similar flow as we did when we went to actually deploy the smart contract, where we need to provide all of the parameters for the constructor, such as the name, the royalty recipient, the symbol, and the royalty BPS. And that allows you to deploy directly from this release page. So you can have multiple copies of your release. Maybe you want it to be on multiple different blockchains. You could release it onto Polygon as well as release it onto Ethereum, for example, directly from this release page. So if you've made it this far and you're looking what to do next, First of all, congratulations on building out your very own full stack Web3 application. And here on the templates page of the portal, you can find all of the example projects that we have for inspiration for you to get started in building in Web3. So for example, if you want to build a staking application or a token gated website, a marketplace, a play to earn game, we have all of these amazing examples built out for you to start out with, customize to what you want to build, and get started shipping in Web3.